Welcome to the data mining course with applications in the life sciences. This is Professor Lonnie R. Welch, and today I'm going to give you an overview of the entire course by way of this diagram, which is a very nicely designed diagram that I found on the internet. You can see the link where I got this at the bottom of the slide. The data mining process, also called the data science process, many people use these terms interchangeably, data mining or data science. The process follows 5 major steps. Before you begin data mining, you need to figure out what question or questions would you like to answer. If you're in a scientific project, you would need to define the scientific goal. You could think about things like, what would you do if you had all the data? Or what do you want to predict? Or what would you like to estimate? For example, you might want to ask the question, are there specific mutations in the DNA of people who have a particular disease, say a particular type of cancer? And actually, that's the question that we'll be exploring in the course this semester. We'll be looking at a real data set from a scientific study that I'm actually a part of currently, where we're trying to answer exactly that question. The first step, once you've asked the question, is you need to get the data. Sometimes the data may be available, which it is in this case. We have the data, and you'll need to begin to get familiar with the data. And as you do that, you move into the third step of the process, which is exploring the data. You will make various plots. You'll look for patterns in the data. After you've done some initial exploration, you'll go on and you'll build some sophisticated models using some techniques from data mining, data science, machine learning. And when you've built a model, you will then fit your data into the model, and then you will need to test the validity of the model. Finally, once you've constructed a model, you need to communicate the results, which is often done by way of visualizations as well as reports, and you'll get to practice creating visualizations and writing reports that would be used in real scientific projects. And as I said, what we're going to be doing this semester is looking at a real study that I'm currently conducting myself with a collaborator at the National Institutes of Health. And if you complete this course, you will understand the complete process whereby you will be able to take a data set of genetic mutations for patients and come up with an answer to the question, are there mutations, one or more mutations, that have a strong connection to the development of cancer in this group of patients? We'll be looking at patients that have cancer and patients which don't have cancer. And we'll be looking at the data file that contains roughly 8,000 mutations in the genomes of around 400 to 450 individual patients, about 1/3 of whom unfortunately have cancer, and the other 2/3 don't have cancer, and that's referred to as the control group. I look forward to guiding you through the process of data mining this semester, and I look forward to getting to know you